Hi everyone, Professor Bob Young back at you here. Now we are going to get into our use of the law of sines, which we proved in the previous video. Now the law of sines is used to find missing angles and sides of oblique non-right triangles. Now the type of triangles we're going to use when we are using our law of sines are given two angles and a side. So down here on the bottom, you may be given two angles and a side called angle side. So let me go ahead and we'll just throw some angles in here. So they may give you one angle here, a different angle here, and a non-included side. Or they might use angle side angle, which means they give you an angle and included side and then an angle here. Or you may have one where you have two sides. So you may have a side here, a different side given, and a non-included angle called SSA. Now there's some special things going on with this third one. Some people might say SSA is a pain in the ASS, as you see here. All right, so the two types of triangles we're going to look at here are called the acute triangles. These are the non-right or oblique triangles. Now, in these, all angles are acute. So angle A, B, and C are all between 0 and 90 degrees or 0 and pi over 2 radians. Or you might have an obtuse triangle here where angle B is between 90 and 180 or pi over 2 and pi radians if you're talking radians. Now, obviously you can't have two obtuse angles in a triangle because remember, all three angles of any triangle add up to be 180 degrees. So if you had two obtuse, it would be real hard to have that triangle. All right, now notice I did prove the law of sines in my previous video, and here it is here. You've got A over the sine of angle A, side A over the sine of angle A equals side B over the sine of angle B equals side C over the sine of angle C. Now notice this can also be written the other way with the angles on tops and the sides on the bottoms. The ratios that we talked about in math will still hold there. All right. So I guess it's time to go ahead and jump into some examples here. All right, example one says find the missing sides and angles of the given triangle. So this one right here, notice how it's set up. They are giving us angle, and a side that's not between the two angles here. So this is a case of AAS. And also notice with this being a 95-degree angle, this would be an obtuse oblique triangle. So again, non-right. I know some of you are used to doing right triangles throughout the course, but not anymore. So what we're going to do using the law of sines is we're going to find what angle B is, we're going to find what side B is, and what side C is. That's the three missing ones we're going to do here. So let's go ahead and write the formula here. Side A over the sine of angle A equals side B over the sine of angle B equals side C over the sine of angle C. And we'll go ahead and plug in what we know here. We know that this is 6 feet A. We know the sine of angle A is the sine of 39 degrees. Now we can get angle B very quickly here because remember all three angles of any triangle add up to 180. So what I'm just going to do first is knock out angle B by taking 180 degrees and subtracting the other two, 95 and 39 from that. So you may want to get your calculators out at this point. And you may want to set them to degree mode, and we'll go ahead and work on this together. Make sure we get the same answers. All right, I ended up getting 46 degrees for the angle B there, so I'm just going to go ahead and insert that into the law of sines. And then angle C we were given as 95 degrees. All right, so what I'm going to go ahead and do first is do the old fourth grade math that I proved the law of sines with. Remember, cross products of equal fractions are equal. So I'm just going to go ahead and cross multiply and set these fractions equal, which you're allowed to do. So 6 times the sine of 46 degrees will equal B times the sine of 39 degrees. And I think y'all will agree here, once you see that relationship, that you can divide both sides by the sine of 39 degrees, and that will give you side B. Now, I think in the homework it's either rounded 1 or 2 decimal places, so we'll go ahead and just round it 2. So I want y'all to stop the video right now, get your calculators out, make sure you get this answer correct before we move on. So take a minute here. All right, I ended up getting 6.86 feet on my calculator, rounding it to the nearest hundredth or 2 decimal places over. All right, so we can continue this process here by finding C here. Now what I'm going to do is try to show you a little trick to save yourself some time on your homework when you do this. So let me get some colors out here. All right, so you guys all know I like to use colors in my classes, so I can use them here. So I'm gonna do a long distance cross multiplication here, and I'm gonna stay with this first set of the first fraction I used to help me get side B here. And I'll show you it kind of helps when you do this. So let me come down here and go, so 6 times the sine of 95 degrees is going to equal C over the sine of 39 degrees, and divide both sides by the sine of 39 degrees. Okay. And C, we're going to go ahead and do it together and round it as well and make sure we get the same answer. Now look at what I had over here when I first entered this. This is stored on your calculator. So what you can do is just go back to this and input it and just change the 46. my tablet's giving me trouble here. The 46 to 95 here to get that answer. So you won't have to keep typing that whole answer in. So let's do it. Take a pause here, see if you get C correct. All right, so I ended up getting side C here equals 9.5, and all I had to do was replace the 46 with a 95 there. So it's going to save you some time. So let's look at one other thing before we move on to the other examples here. So we found that side B was approximately 6.86 feet. And side C was approximately, rounded 2 decimal places, 9.5 feet. And angle B here was 46. So this completes all the triangle here. And I wanted to point something out before we moved on. Notice that the largest angle is opposite the largest side now, and the smallest angle is opposite the smallest side. So make sure when you get answers, yours fits that format. All right, the largest side will always match the largest angle, the smallest side will always match the smallest angle, and in between here as well. All right. Example 2, find the missing sides and angles of this given triangle. Now this one is an angle side angle, if you notice here. All right, and we want to find in this one angle A and sides B and side C. Now notice this one I labeled 9 miles. Now this is just the uniqueness of trigonometry. I mean, these relationships could work with any units. I mean, feet, yards, miles, inches, yards. I mean, so trigonometry, very important as far as being able for us to calculate many things. So let me go ahead and put A over the sine of angle A equals B over the sine of angle B equals C over the sine of angle C. And we'll put in what we know here. We know that angle C is 55 degrees. Angle B is 52 degrees. And angle A we can find very quickly, again, given the other two, by taking 180 degrees and just subtract these two. So very similar to the first example here. And I may let you all pause and see if you can get sides B and C. as we progress here. So that's the beauty of teaching online sometimes, and the beauty of you having, being able to watch this versus seeing me in person. I mean, in class, you can't stop, pause, rewind, fast forward me like you can now. All right, so let's go ahead and we'll get this angle and we'll continue. All right, so I ended up getting 73 degrees to make sure all of those add up to 180, so I hope you did as well. All right, so what I want y'all to try to do now is let's take side A, which they said was 9 miles, and plug it in here. And you do your cross multiplications and so forth. Now, again, I would use this one, this relationship right here, to get both B and C, because it'll just save you work and time entering it in your calculator. So go ahead and pause. And of course, I'm going to go ahead and work it out as well here and see if you can get B and C, and then I'll be back with it. All right, so I'm just popping back in with a whole bunch of work done here, and I'm going to explain how we got it, so make sure y'all are following along and getting it on your own. So I took 9 cross multiplying here, cross products of equal fractions are equal, times the sine of 52 degrees equals b times the sine of 73 degrees, divided both sides by the sine of 73. Make sure you're in degree mode. I got b equals 7.42. Now I'm going to pause, you pause, and see if you can get C using this first triangle again, and then you won't have to enter so many things in there. All right, so I went ahead and wrapped this one up in red, and see if you people, I love the colors. You can use your colors as well. I took 9 times the sine of 55 degrees and set it equal to C times the sine of 73 degrees, divided both sides by the sine of 73 to get side C as 7.71 miles. So I've got all of my problem completed here at this point. And in addition, notice when I stayed with this first triangle here, when I had all of this to get side B, all I had to do was change the 52 to a 55 without having to retype all that in there. So that'll save you a little bit of time, as well. All right, so let's go on and continue the adventure here. All right, now of course you know that if I've already done an angle side example and an angle side angle example, Young is going to come back with the side example. And now they call this the ambiguous case. Now what happens here is we have to look at the height of these oblique triangles, and based on what they give us, there are different outcomes. All right. So for example, let's say that they give you an acute triangle, and side A, as you see in this picture, is less than H. Notice that this triangle does not even connect. And what happens is if you try to do the law of sines with this, you'll get it all set up and you'll start doing things. When you go to hit something, you might get error or something of that nature, and you'll say, uh-oh, I think it might be one of these where it has no solutions because of the way they set it up. Now notice if it's a right triangle here, it's kind of defeating the law of sines purpose anyway, because I might use my right triangle principles in order to solve this one. All right, but you're only going to have one set of solutions like the ones we've been doing. If A is an acute triangle, now notice these first 4, A is a acute right or acute oblique triangles, non-right. And if A is greater than B, you can kind of look at the sides here. You'll get one set of solutions. So, these two here are not going to be much different than the ones we did. There's also cases where you have obtuse if side A is less than or equal to side B. That isn't going to happen. You're not going to get answers to this one. It's going to be error on the calculator. If A is greater than B, one set of solutions. So all of these are either going to be none or one. Now they do have some exercises in your homework about this, but what we're going to do is we are going to do this one that has 2 sets of solutions. I mean, this is the absolute worst one that someone could give you. And this is the case where you have the height here. The height is less than side A is less than side B. You will get not 1, but 2 sets of answers here. So I'm going to do one example with two sides and an angle with the two case scenario. So here we go. So it says find the missing sides and angles of the given triangle here. And notice that if I dropped a perpendicular down here and I called this the height, which I think I'm going to do, we'll do that real quick and show you that this is certainly going to be the case here. All right, so what I did is I went ahead and dropped a perpendicular here, and I called this side H. So I think y'all would agree with this, that the sine, looking at this left to right triangle, the sine of 53 degrees is going to equal opposite over hypotenuse, H over 16. Multiplying both sides by 16, H is going to be about 12.78. So notice this is a prime example where you'll have two sets of solutions in this given right triangle, given two sides and an angle here. So H is certainly less than side A is less than side B, just looking at all of this. All right, so I am going to clear all of this off, and we'll come back and we'll get the first set of solutions just like we've been doing. That's going to be easy enough. So let me pause. All right, so I went ahead and I cleared off some things there, showing you that we found out that H value here. So what we're going to do is just treat this like we've been treating the previous two examples. So I just went ahead and wrote the law of sines here. But notice in this example here, it's a little different. You can't just get the next angle that easily. You're going to have to work for this one a little bit. So let's cross multiply these, and we'll get 14 times the sine of angle B equals 16 times the sine of 53 degrees. Divide both sides by 14, and we will get the sine of angle B is equal to 16 sine 53 degrees over 14. Now guess what time it is, ladies and gentlemen? To get that second angle, we are going to use what? Take the inverse sine of both sides, or the arc sine, or what Young likes to call the angle getter. All right, so I want you guys to pause right now and see if you can get angle B, and we'll just round it to the nearest whole angle is what we'll do on this one. So take a second, pause, do it. All right, I ended up with about 65.884, so I just rounded it to 66 degrees here. So now we can say that this is 66, which means now we can get side C, and we can just finish blowing this one right out of here once we know that this is 66. All right, so we'll go ahead and pause now to get the third angle here. We're just going to take, like we've been doing, subtract 180. 66 and 53, and then I want y'all to go ahead and finish and get side C as well in this first set of solutions, and then we'll come back and keep working on this one. Alrighty, so what I went ahead and did is I took to get angle C, I took the 180, subtracted 66 minus 53, so that gave me 61 degrees. And then I went ahead and read, and I said 14 times the sine of 61 equals C times the sine of 53 divided by the sine of 53 degrees. And I ended up with the first set of solutions here. C is 15.3 inches. So you can again see that the largest side is opposite the largest angle, smallest side opposite the smallest angle, and so forth. But wait, there is more. Just hang on here a second. All right, now what happens in these two solution cases is that what we're going to do whenever H is less than A is less than B, you can take this line segment or side CB and you can fold it in to where we make a new side CB. So this is what's called an isosceles triangle, these two sides. So in other words, A is still going to be 14 inches. We're just going to take this and fold it in here. So this side now has become green over here. Now notice the problem has not changed. The things we were given this side, AC, which is side B, is 16 inches. Angle A here is 53 degrees. And the A side we just folded in is now over here in terms of a green angle. Now, in an isosceles triangle, you should realize, and if you don't, that since these two sides are the same, these two base angles here are going to be the same. All right, so what we're going to now do is find the solutions in this real skinny triangle here. All right, so we're going to have a new angle B here. We're going to have a new angle C, and we're going to have to get a new side C here as well, because see, this is angle C, and there is a little side C in between there. Now, don't think this is going to be super difficult. It might look like it is, the two case ones, but right away, you know, at least I hope you know, oops, I almost messed that up there. Um, you're going to get what angle B is very quickly because these two angles are supplementary. They form a straight line. See, so if we take 180 and subtract 66, that is going to give us the new angle B. Now remember, angle B in our first set of solutions was 66 degrees, but notice we have gone from what was an acute triangle to this one's going to be this real thin one here, an obtuse triangle. So maybe I should come up here and put the new B, or the new B, so to say. All right, so I just subtracted 180 minus 66, and the new B is 114 degrees. So now I can get this new angle C by taking 180 minus the 114 we just got there, minus angle A is not changed since the start, is 53. And notice C is going to be a very small acute angle. It's going to be a Sharpie. So I ended up with 13 degrees for that one. See, so this one's going to have two sets of solutions. So let me go ahead and write everything out here, and we will see that real skinny triangle with the green side will be the second set of solutions, which I think y'all can get from here. So let me go ahead and fill in things and come back. All right, so to get the side C now using the second set of solutions, I'm just going to take these outer two fractions here and say 14 times the sine of 13 degrees equals C times the sine of 53 degrees. So C would equal 14 times the sine of 13 degrees over the sine of 53 degrees. And notice side C is going to shrink tremendously here in this set of solutions because it was in the original triangle was 15.3 inches. Let's see what we get here. So I got the second C is about 3.9 here. So that is how it works for the worst case scenario. All right, now in the homework, you're going to be given some other triangles and so forth to find the missing sides or parts using the law of sines, but this is one of my favorites as instructors because it uses both our previous work with right triangles in addition to the law of sines in order to get certain things. So I want you to take a minute, pause, look at this triangle, and see if you could reason out, given what you're given here, how to get A, and then I'll come back and we'll work on it together. All right, now there are several ways to attack this problem on how to get side A here, but what I'm going to do is use this thin right triangle here to get this side, the hypotenuse, and I'm going to call it X. All right, so I'm going back to my right triangle trigonometry here. So notice on this one, I'm going to say, to get X, I'm going to take the cosine of 10 degrees, and I'm going to say that equals adjacent 120 over X. And I'm going to go ahead and solve for X, and we'll go from there. All right, so I went ahead and solved, and I got 121.9 for X. Now I think y'all see that you can go ahead and find this angle very easily too, because they gave us 22 degrees and 100 degrees here. So this angle up here we'll call it angle B, I mean, we can call it anything, equals 180 degrees minus 100 minus 22 degrees is going to equal 58 degrees right in here. Okay. Now we can use the law of sines if we're sharp here to get this side by saying A over the sine of the angle opposite A is 22 degrees equals, we'll say X is 121.9, which we found that hypotenuse in this right triangle, over the sine of 58 degrees. See, so the 22 degree angle matches up with A here, what we're after. 58 degrees would match up with the 121.9, and we could even find this side if we wanted to by taking the 100 and matching it up over here, but we were just asked to solve for A here. So I'll let you all pause, stop, and see if you can get it, and we'll go from there. All right, so I went ahead and cross multiplied, set those equal, and I ended up with side A is about 53.8. So you'll see a few of these type problems in the homework. They're kind of like puzzle problems. I like them. All right, now finishing out the examples for the law of sines, there's some other applications that have been derived from this, and one is to how to find the area of any oblique non-right triangle. And remember, the area of a triangle anyway, if you remember your basics, is 1/2 base times height. So with the law of sines involved, here is what the formulas look like to find the area. So depending on what sides and angles you're given, the three formulas for the area of an oblique triangle is 1/2 times side B times side C times the sine of angle A, and you can kind of look at the others. So if you're given some problems in the homework, such as example 5 here, notice we're given angle A, side B, and side C. I think you'll easily come to the conclusion of which one of these to use. All right, so this really is just a plug and chug problem here. So the area of this oblique non-right triangle would be 1/2 times B is 20 feet times C is 50 feet times the sine of angle A is the sine of 22 degrees. Sorry, that's a bad eye there. And then it says round it to the nearest foot. So go ahead and do that on your calculators real quick. See what you get. Pause this. Make sure we're all getting the same answer. All right, so I just took half of 20 is 10 times 50 is 500, and I put 500 sine 22 degrees in my calculator. I ended up with 187.3, so about 187 feet would be the answer to that problem. Example 6. I've drawn a beautiful picture for y'all. Actually, I just copied and pasted it out of some materials I have, and it says the surveyor needs to determine the distance between 2 points that lie on opposite banks of a river. So the figure shows that 300 yards are measured along one bank, along the top here. The angles from each end of the line segment to a point opposite the bank are 62 and 53 degrees. So, you know, surveyors have those machines where they can stand out there and make sure they measure angles and so forth. So it says find the distance between A and B here, and look at, we can use the law of sines and do this without even getting our feet wet. And it says round it to the nearest tenth here. All right, so what we want to do first is probably get this angle B here, and I think y'all know how to do that very quickly. So some of these application problems in this section are much easier than some of the other problems because they're not so involved. You don't have to go and find all these missing parts and pieces and go crazy here. All right, so I found angle B is 65 degrees. So if we are after AB here, we'll go ahead and call this X. Again, you just have to make sure you're careful with how you're setting things up. So we're going to say that the 300 yards that they measured across the bay there, or the river, matches up with the sine of 65 degrees. And since we're after this angle here, we're going to say x matches up with, do you see the sign of what in this one here? Hopefully you do. Is the sign opposite x is 53 degrees. So I'll go ahead and let you pause here and get x and round it to the nearest tenth. Make sure you get it, and we'll be well on our way. All right, so I ended up with 264.4 yards here, and noticing the 300 was probably going to be the longest side matching up with the largest angle, so I think that answer makes pretty good sense here. And we could also figure out this other side, BC, if we were so inclined. All right, so let's do a few more examples where you can actually use these creatures, this trigonometry in real life, and we'll go from there. Example 7, when the angle of elevation of the sun is 62 degrees, so that's if we were standing on the ground and looking directly up here, a telephone pole that is tilted at an angle of 8 degrees directly away from the sun casts a shadow down here that's 20 feet long. Now it wants us to determine the length of the pole rounded to the nearest tenth of a foot. So I'm going to pause here. I'm going to come back. I know I come back quick when I pause, but I want you to pause and look at this and see if you can reason this one out. All right, now this is a good exam review. I don't know if y'all saw this, but if this one's 8 degrees, this looks like a right angle in here. Do you remember what these two angles are called? Two angles that add up to 90 degrees. I'd probably be picking on someone in class if we were in there. What are they called? And people would look away from me. But they are complementary angles. So if this one's 8 degrees, this one would be 90 minus 8 degrees would be 82 degrees. And then we're after the height of this telephone pole here. So I'm going to go ahead and put H here. All right. Now notice again, they're jerking our chains because they gave us this side that cast the shadows 20 feet. So now in this triangle that contains the pole, we're going to need that angle. But I don't think anyone's going to have a problem getting it because we're just going to take that and take 180, subtract 62 degrees minus 82 degrees, and then we can use the law of sines to calculate the height of that pole to the nearest tenth of a foot. So that third angle we were just after is going to be 36 degrees. So let's make sure you set this up right. So if you want to pause and set up the height of the pole in relation to all these parts now, do so. But I'm just going to go ahead and continue here. I'm going to say that that 20, the shadow that the pole is casting, matches up with the sine of 36 degrees equals the height of the pole, which we're after, matches up with the sine of 62 degrees, and then we'll just do our cross multiplication and solve here. All right, I ended up with 30.04 on this one, so I guess if they want us to round to the nearest tenth of a foot on this one, it's just going to come out 30 feet would be the height of the pole. So I multiplied 20 times the sine of 62 equals h times the sine of 36 divided by the sine of 36 degrees to get that solution. All right, well, I hope I've done enough examples for you to go in there and pound on that homework for the law of sines here. If not, you know there's lots of help aids. There's lots of ways you can ask me questions. Make sure you do so, and I'll be happy to always help you. Bob Young signing off, Law of Sines.